In this video, we're going to solve the absolute value inequality. Absolute value of 3x minus 10 minus absolute value of 4 minus 2x is greater than 1. All right, so first thing, let's rewrite that inequality. And what we're going to do is we're going to set each argument equal to 0 and solve for x. So if I let 3x minus 10 equal 0, then ultimately I get x is equal to 10 over 3. And if I set 4 minus 2x equal to 0, ultimately I get x is equal to 2. So we're going to build ourselves a master number line that's going to have an x value of 2 and an x value of 10 over 3 marked off. I'm going to build a couple of walls here to help us really see what the restrictions are. Now, to the left of 2, 3x minus 10 is less than 0. If you don't believe me, plug in any number less than 2. For instance, 0 for x, and you'll see 3x minus 10 is less than 0. Well, if 3x minus 10 is less than 0, then that means when we're to the left of 2, absolute value of 3x minus 10 is equal to negative of 3x minus 10, which is negative 3x plus 10. Now, to the left of 2, 4 minus 2x, which is the argument of the second absolute value, that's actually greater than 0. If you don't believe me, plug in a number less than 2 for x, say for instance 0. 4 minus 2 times 0 is definitely greater than 0. So we can say the absolute value of 4 minus 2x is equal to 4 minus 2x over here. Now, if we're trying to solve the inequality absolute value of 3x minus 10 minus absolute value of 4 minus 2x is greater than 1, then what we're going to do in this interval is re-express it as negative 3x plus 10 minus 4 minus 2x quantity is greater than 1. We get negative 3x plus 10 minus 4 plus 2x is greater than 1. Which leads to negative x being greater than, if we add 4 and subtract 5 from both sides, negative x is greater than negative 5, which means x is less than 5. So now, 5 is not actually in this interval, but what we're doing is we're asking ourselves, what values of x that are less than 2 meet the condition of x being less than 5? And the answer is all of them. Literally every value of x in this interval, the interval is defined as those values less than 2, all of those values are also less than 5. So we are going to shade in everything to the left of 2. All right, let's move on to the next one. Now, in between 2 and 10/3, think of a number, for instance, 3. If we evaluate 3x minus 10, we'll get a value less than 0. For instance, 3 times 3 minus 10 is less than 0. Well, that means that the absolute value of 3x minus 10 is going to equal negative of 3x minus 10, which is negative 3x plus 10. Okay? Now, in this interval between 2 and 10/3, 4 minus 2x will be less than 0. For instance, let x be the number 3. 4 minus 2 times 3 is less than 0. So the absolute value of 4 minus 2x will equal negative quantity 4 minus 2x, which is negative 4 plus 2x. Okay, now to solve the inequality that we're given, the absolute value inequality up top, which is absolute value of 3x minus 10 minus 4, absolute value of 4 minus 2x greater than 1, we're going to sub in negative 3x plus 10, and we're going to sub in negative 4 plus 2x for the absolute values shown. We get negative 3x plus 10 plus 4 minus 2x is greater than 1. We collect like terms. On the left, we get negative 5x. We subtract 4 and subtract 10 from both sides. We get negative 5x is less than negative 13. Dividing both sides by negative 5, we get 13 over 5 on the right, and we change the direction of our inequality. Now, 13 over 5 is in between 2 and 10/3. It's right about here. So what we're going to do is we are going to shade in all values in our interval which meet the condition of x being less than 13 over 5. So we're going to shade in everything in between 13 over 5 and 2. Now finally, we're going to look at the far right. To the far right, if x is greater than 10/3, for instance, if x is a number like 4, 3x minus 10 is greater than 0, which means the absolute value of 3x minus 10 is equal to 3x minus 10. 4 minus 2x to the far right is actually less than 0, meaning the absolute value of 4 minus 2x is equal to negative quantity 4 minus 2x, which is negative 4 plus 2x. So our inequality up at the top, which I am rewriting now for clarity, that inequality can be re-expressed as 3x minus 10 minus the quantity negative 4 plus 2x is greater than 1. So 3x minus 10 plus 4 minus 2x is greater than 1, which means x is greater than 7. So what we're going to do is we're going to shade in all values of x greater than 7 that are in the current interval. Now those values of x which are greater than 10/3 and also greater than 7 are all values greater than 7. So we're going to shade that in like that. Now at this point you might be saying to yourself, how about the 2 and the 10/3? Should I shade those in? If you're not sure, simply plug in a 2 to the original inequality and see if you get a true statement. 3 times 2 is 6, so what we're doing now again is we're testing this x value of 2 to see if we should shade it in. The absolute value of 6 minus 10 minus the absolute value of 4 minus 4. The absolute value of 6 minus 10 is the absolute value of negative 4. 4 minus 4 is 0. Now, the absolute value of negative 4 is 4. The absolute value of 0 is 0. Is 4 minus 0 greater than 1? Yes. As a result, we are going to make sure that we shade in that circle right there. Now, do we shade in the 10/3? Well, which is this guy right here. Do we shade that in? Well, let's find out. 3 times 10/3 minus 10 in absolute value brackets minus 4 minus 2 times 10/3 being greater than 1. Well, 3 times 10/3 is 10. So I'd be saying the absolute value of 10 minus 10 minus, we've got 4 minus 20/3. 4 is equal to 12/3. 12/3 minus 20/3 is negative 8/3. Now, 10 minus 10 would be a 0. The absolute value of negative 8/3 is actually 8/3. So what we're doing is we're testing is 0 minus 8/3, because the absolute value of 0 is 0. Is 0 minus 8/3 greater than 1? Well, clearly it's not. So we are not going to shade in that value of 10/3. So now we can look at that upper number line and say there's our solution set. Our solution set is going to equal the set of all x's element of the reals such that x is less than 13 over 5, x is greater than 7. Okay, and to state that in interval notation, which is also requested in this question, we would say x is an element of the interval between negative infinity and 13 over 5 in union with the interval between 7 and positive infinity.